My name is Matthew Beam, and I'm a research specialist here at the Rubenstein School of Environment and Natural Resources. I specialize in ecological design and living technologies. Nature is incredibly good at cycling energy and nutrients and not creating waste. The very idea of waste is just an opportunity in nature. If we can learn what the pond or the forest or all of our great ecosystem types know, we can redesign our systems to work similarly. We can really find synergies and increase the efficiency of how we do things. An eco-machine is a designed and assembled ecosystem that is directed for human use. We provide the scaffolding, we create an environment, and then we assemble organisms that can do biophysical work within that environment for our benefit and for the benefit of nature as well. The eco-machine in the Aiken Center is designed to purify all the wastewater generated within the building. And this includes toilets and urinals, floor drains, the showers, you name it. Purify it to swimming water standards and then to reuse that water for flushing toilets. This system is the first reuse system in the state to use UV sterilization instead of chlorine, and we think that we'll be able to reduce the water consumption of this building by 2/3. In a typical wastewater treatment plant, you find a suite of organisms and you pitch these organisms into your reactors. They grow up huge populations and you artificially control the environment so that the populations get much larger than they would in the natural environment. And they eat everything that's in the water. Then you slow down the water in a clarifier and they all settle out and they form what's called a sludge at the bottom, dead and dying microorganisms. And what you're left with is the clean water that they've consumed everything out of that you pour over the top. They're very efficient and very good systems, but they are a little unstable because they require so much human control. Now, an eco-machine, on the other hand, instead of finding the most efficient bacteria, we find the most efficient ecology. And the way we do that is we collect environmental samples from ponds, lakes, streams, wet spots in the woods, farming areas, compost piles, and we spin a whole web of life off of it. And we ask nature what it would do. And the whole concept behind this is called self-design. 3 billion years of evolution, all these organisms have been working together, and they will self-design themselves around your waste stream and around your environment. But we theorize, and this is one of the things that this facility is designed to test, that ecologically designed wastewater treatment systems incorporating all these organisms together should be more efficient over time. They should be more stable. In other words, you'll have less crashes. The Aiken eco-machine is designed specifically for research. So you're not looking at one eco-machine here, but you're looking at 3, and they're running parallel to each other. Everything exits the building about 26 feet below ground. So the very first thing we have to do is pump up to a septic tank. Septic tanks are basically the first part of any wastewater system the whole world over, and there's a good reason for that. You can remove almost 90% of the nutrients and the solids in water simply by slowing it down. That's what septic tanks do. Each hour we get a pump cycle. Hour 1 would go to train A, hour 2, train B, hour 3 to train C over to that other tank. And then at hour 4 we'd come back to train A. Now the first treatment unit we have in this room is a closed aerobic reactor. It's called closed because it's sealed off to the atmosphere. The water coming into this tank is really disgusting. It's full of methane, it's full of hydrogen sulfide, it's full of mercaptans. All of these noxious gases get driven out of this water and out of this tank through this flexible tube, and those go up into these elevated biofilters. Now these are full of wood chips and compost and a little bit of topsoil, and then we plant the surface and keep this soil and compost moist. And what happens is the gases diffuse into the water film, and the microorganisms present, they use those gases instead of oxygen for their energy source, and then they break down the wood chips and the compost for their carbon. And they literally grow off of what we're worried about. And these tanks are open to the room, so all that air is coming up through those filters and we're breathing it. And it doesn't smell at all in here. The water in this tank will be very dark and thick and murky, and that's good. That's a good thing, because that just means we're getting a lot of microbial activity. And those microbes then drive the ecosystems that we grow off of them. They become the base of our food web. Water then flows out of the closed aerobic tank, and each train has a series of 3 open aerobic eco-machine tanks. Now, these are the iconic systems that most people think of when they think of a living machine or an eco-machine. And the major elements are a tank, and sometimes, and in this case it's true, they have clear-sided tanks. And this is a good benefit because it allows light to penetrate the water column. So we get algal growth and we get autotrophic bacteria, a whole functional group of life. They are all wetland species, and so they have systems to bring oxygen down to their roots. Having plants reduces A, the amount of oxygen you have to pump, but B, the root zones form these dense filtration units. The water is flowing through each one of these, and it's progressively getting cleaner and cleaner. And while it might look similar, there's a different ecology arising in each tank because the water chemistry is different coming in, and they self-organize around it in a specific and different way. The water chemistry is very clean at this point, but it's full of particulates, algae and plankton and macroinvertebrates. Now we need to get rid of them. And that's where these constructed wetlands come in. And we're using this instead of a clarifier. This is water that came out of the wetland and is being recirculated, and you can see how clear the water coming out of this is. After the wetland, everything flows back together in our collection sump. We will take the cap off of that pipe, and then that pipe goes to the basement. And that's where we have our treated water storage and our UV filters for disinfection. We are charting new territory in ecological design. When I showed up at UVM in 2002, I had no idea that this is where I would end up. After about a year of studying here, I got very interested in ecology. I got very interested in the Rubenstein School. And so I signed up, and I gotta say I was not disappointed. I knew that this was what I was going to do. My master's project was the design of this facility, and then subsequently I was hired to build and work with it.